Sir, Mohan sir, shall we start, sir?
Yes, sir. Yes, sir.
Okay, sir. Let me introduce, sir.
Oh,
Before
okay.
that, dear participants, very good morning to everyone present here. I welcome you back for the third day of the ATAL FDP program on alternate fuels. Before proceeding with this session, there is an announcement. As per the schedule, there is a change. Okay, due to unavoidable reason, due to the speaker's availability, so there is a change. So instead of tomorrow afternoon session, algae oil by Dr. T. Mohan Raj, so that session has been shifted to today first session, and today's session will be mutually changed to next tomorrow afternoon session. Okay, there is a mutual change between these two speakers. So this is an announcement. So sorry for the change in the schedule. So now I'm glad to introduce Dr. T. Mohan Raj, Senior Assistant Professor from the School of Mechanical Engineering, Sastra University, Tanjavur. Dr. Mohan Raj is having more than 22 years of research and teaching experience, and he is a postgraduate in energy engineering from NIT Trichy, and PhD in the area of biodiesel application with variable compression ratio engine. We could see many research articles related to alternate fuels in reputed journals, conferences. So numbering around 35, we able to see with very good citation impact. Mohan Raj is also having consultancy work with engine performance for power tillers, Kavi Agro Industries for Trichy, and a research project under the title Turbocharged CRDI Engine with Biodiesel from DST Serb. So with this few, say the achievements of the speaker, I introduce you to the audience, and I welcome you, sir. And I hand
Thank
over
you,
the
sir.
session,
Thank you, sir.
and I hand over the session to Professor T. Mohan Raj. Please, sir.
Okay, sir. Thank you, sir. Good morning to one and all. Participated in this ATAL program, and I want to say one important things. So during this COVID-19 pandemic period, so you are involved and interested to participate to get the to share the knowledge. Okay, through this online mode, I'm very happy. Okay. Instead of ideal, some things you want to get some develop this idea, knowledge in your mind. Okay. It is important. What it is motivated things for researchers. Okay. So welcome to all for this session. So this my topic is algae. Okay, so my topic is algae oil. In this algae oil comes under the third generation. So why it is called third generation means, so imagine olden days. So olden days that locomotive engines. Okay, in olden days that locomotive engine, the coal, whatever form the coal available, coal mine, it is directly used in the furnace. Okay, that coal is directly used in the furnace without that pulverized coal or without size reduction. So not that much idea. Olden days only that coal is available in this coal mine used for to generate steam. Okay, and that steam is supplied to the steam engine. So that is old version. Okay. Then second generation by this Rudolf Diesel. Okay. We produced this. We developed an engine for using the internal combustion engine and external combustion also. So even engine also used coal. Okay, in solid form they are used tried with this engine also. Okay, so that is a different issue. But in this modern years, 2020, okay, they are reaching more than 100 years from this development. Okay, so now we are come to this third generation algae. Everybody knows algae is nothing but That is, it is grow in this saline water. Okay, so algae grow in the saline water. So mostly seashore area, we have to observe that some cuddle posse. Okay, so that posse, in Tamil it is called cuddle posse, but even that some normal water also it may grow. Okay, very fast. That is the advantage. Okay, so in between this old generation, first generation, second generation. So why this algae is important means, okay, that yield. The important point is yield. Even we have to generate, we have to produce biodiesel from vegetable oil or some other source. But from the algae, it gives maximum 70% yield. For example, if you go for vegetable oils, 50%. At the maximum 50%. But if you go for algae oil, it gives maximum 75%. Okay, so that is a new trend in this biodiesel preparation from the algae. Source only algae. Okay, but other method, esterification, trans-esterification. So before that process, okay, we go for some characterization, free fatty acid. Based on the content of the free fatty acid in the oil, we have to use the catalyst for acid base. So this is all common for all the biodiesel production. But okay, think the source only different. Okay, so this is about the algae oil. Okay, so what about this voice? It is audible, everyone? Hello.
Yes, sir.
Yes, sir. It's audible, sir.
Okay, okay. Voice audible. What about presentation is there now?
Yes, sir.
Okay. Shall we move one by one? Okay. You have any
Mohan Raj, sir, slideshow.
tell me,
Slideshow.
tell me.
Slideshow,
Okay,
sir.
I will
you
move,
have-
sir. Yeah, I will move to the second slide. Now it's
No,
okay,
sir, you
sir.
have not put the slide mode, slideshow mode.
Now it's okay.
It's okay, sir. Slideshow.
Slide so only is there, sir. Now I changed the slide so.
No, sir. Full screen, sir. Requesting for full screen.
Now full screen, sir.
No, sir. The next
Hello?
option, sir. Next to next option, sir. You click there, no, sir. The next option.
Okay.
Just below, sir. Just below. Yes. That one, sir. That one.
Correct.
Sir, kindly press F5, sir. F5 is the shortcut.
Huh?
Kindly press F5, sir. F5 is the shortcut for presentation mode.
F5. Now okay, sir. Hello.
Sir, we are not able to see the full slide.
I press F5 also.
Okay, sir. You proceed, sir. Please proceed, sir.
One minute. I will try another option also.
Sir, use function button, sir. Function F5.
Function F5. Huh? Sorry, visible now? Hello?
Not, sir. It is not visible. No, sir. No.
Sir, could you please try Shift F5 once? Shift F5.
Shift F5. Clear, sir? But in my screen, this full screen only.
I don't know what is the reason, sir. I could not set right there. Okay, you better continue, sir. We shall see.
With this mode, can I continue?
Continue, sir. Continue, please.
Okay.
Sir, there is
So,
a option at the top, sir.
ah.
Home, Insert, Design, Animation, Slideshow.
Okay.
From the current slide, it will be,
Make,
sir.
sir.
From the beginning or from the current slide?
Now okay.
I know.
Something went wrong, sir. You carry on, sir.
Oh, okay. Okay, sir. Biodiesel. And the biodiesel is generally called as a biodiesel is nothing but a methyl ester. Okay. So biodiesel is a methyl ester of fatty acid. Full screen now. நாங்க visible இல்லையே. Sir, now visible? Hello?
No, sir.
வரல.
I think there is some from your end only it is.
I tried this slide show and also from the beginning.
Yeah.
FI also.
சார் ஏதாச்சும் டயலாக் பாக்ஸ் ஓப்பன் ஆயிருக்கா பாருங்க சார். அது இருந்துச்சுன்னா வராது.
வராதா?
ஆமா சார், ஏதாச்சும் டயலாக் பாக்ஸ் ஓப்பன்ல இருக்கா பாருங்க. அது இருந்தா க்ளோஸ் பண்ணிட்டு ட்ரை பண்ணி பாருங்க சார். அதர்வைஸ் யூ கண்டினியூ சார். விசிபிள் ஒன்லி.
Now okay, sir.
சார் பிரசன்டேஷன் வரல.
பிரசன்டேஷன் வரல. Sir, what about now, sir?
Sir, still it is the same manner, sir. We cannot see. You do one thing, sir. You can increase the magnification. That is around 67% it is showing.
Okay. There, okay, correct.
You can increase that one, sir. No, sir. Still, you can reduce, sir. To manage, sir, according to the window size. Okay, sir. Okay.
No, okay, sir.
Okay, sir. Okay.
Okay. So, okay, sorry for the inconvenience. I will. Okay. So, biodiesel is nothing but a methyl ester of fatty acid. Hello. Okay. It is a renewable fuel and a substitute for diesel. Sir, some echo. Hello.
Sir, echo over there.
சார் நீங்க ரெண்டு டிவைஸ் ஓபன் பண்ணிருக்கீங்க நினைக்கிறேன். ஒரு டிவைஸோட மைக் ஆஃப் பண்ணிட்டீங்கன்னா எக்கோ வராது.
Hello. Okay, sir. Now clear? Yes, sir. Yes, sir. Yes, sir. Yes, sir. Okay. So biodiesel is a methyl ester of fatty acid. Okay. Both we have to derive from vegetable oils. That vegetable oils also either edible or non-edible. But if you go for use of the edible oil means sometimes food versus fuel conflict will arise. Okay. Suppose you are going to use the edible oil as a fuel means sometimes for cooking purpose we have to create some demand. That's why they have to focus on only non-edible oils. Okay. So in this way, the algae also importance role for the preparation of biodiesel for the engine as the alternative fuels. Okay. So even for edible or non-edible or algae fuels, we go for two methods for the preparation. One is called esterification, another one is called trans-esterification. In the case of esterification process, we have to use the catalyst. If it is free fatty acid content more than 4, we have to use the esterification. In the case of trans-esterification, sometimes that oil content, the viscosity is less, the fat also minimum, then directly we go for the phase 2, that is second phase, okay, by using base catalyst, NaOH. Okay, these are the method for the preparation. Okay, then the biodiesel is a renewable fuel. Okay, renewable fuel as well as oxygenated fuel. Okay, actually for the combustion it requires oxygen. Okay, air fuel ratio from the air that nitrogen and oxygen is there. Okay, but suppose you are going to use the renewable, that biodiesel, that fuel itself some amount of oxygen is there, that is also for enhance the combustion or reduce the emission. So these are added advantage if you are going to use the biodiesel in the diesel engine. Okay, does not contain any petroleum product. For example, if you are going to use the petroleum product, that is refined crude oil from the oil well. Okay, so from that oil it is hydrocarbon fuel. Okay, but in the case of biodiesel it is oxygenated fuel. Hydrocarbon fuel automatically if you are going to burn used in this combustion, okay, hydrocarbon also as emission, CO2 also emission. Okay, but in the case of biodiesel, the content is less compared with the conventional fuel. Okay, and esterified version of vegetable oil. Okay, before that we called as raw oil. After esterification, trans-esterification, it is called esterified vegetable oil. That is called biodiesel. Okay, so now these properties and also their characterization according to this condition. Okay, it is universally accepted clean alternate fuel as in the for the engine, IC engine. Okay, the importance of biodiesel was discussed earlier. Okay, the founder of diesel engine, Rudolf Diesel, so already suggested in future. Okay, the importance of vegetable oils is discussed in the year 1912 itself. Okay, the use of vegetable oils for engine fuel may seem insignificant today, but such oils may become in the course of time. Now it is true. Okay, that importance of biodiesel. So why? Because of that biodiesel importance means you can compare with the price of diesel, petrol with the last 5 years or even last 10 years. Okay, so totally 2 times. Previously at the maximum 50 rupees only. Now it is around 89. Okay, but diesel is 82, petrol around 90 like this. Okay, so that's why. So it may be importance for this current situation. Okay, the need for biodiesel. Okay, so whenever if some demand is there or need is required means some reason. So like this for the biodiesel also 4 important reason. So why we are moved to this that third generation as well as alternative fuel. Okay, so the first and the foremost thing was fast depleting conventional fuels. Okay, so as per the Society of Automotive Engineering's report, 2035 coal may not be available. Similarly, 2050 petroleum fuel will not be available. Okay, so this is as per the prediction as well as per the Society of Automotive Engineers report. Okay, it may be varied. Instead of 2050, maybe 2055. Similarly for the coal, instead of 2035, 2040, some slight variation is there. Okay, so almost in Indonesia is a major place for coal mines. Okay, so due to natural calamity and the natural problems. Okay, so nowadays there also the coal availability is reduced. And the second reason, okay, for the biodiesel importance, frequent increase in cost of conventional fuels. Okay, olden days the price also increase every 6 months or every 1 year, around 1 rupees or even 2 rupees. But nowadays every day. So every day, and that moment begins. Okay, so after 12, okay, that midnight after 12, the next day morning. Okay, 12.1 itself, in every bunk they are reset the value. Okay, even 0.5 paise or even 2 paise, whatever may be. Okay, so price is increased. But if it is any reduction, okay, any surplus amount, but the reduction is less. For example, in 2011, okay, that usage is 1.5 lakhs barrel. But in it is expected, but it is still we are using 3.5 lakhs barrel. So it is also from this survey of this economics, okay, times. And another one necessity, okay, number of vehicle usage increases every day. Okay, so imagine the two-wheeler and the cycle. Okay, 50 years back, two-wheeler cycle ratio only is there. Now the comparison is with four-wheeler and two-wheeler, that bike. Okay, so cycle usage. Cycle is more advantage for health-wise as well as emission-wise. Okay, fuel cost. Okay, but nowadays even for travel some less distance also we are using two-wheelers only. Okay, so that's why the third important, first one is fast depleting conventional fuel, second one is frequent increase of fuel cost, third one is vehicle population. Okay, so vehicle usage also increases every day. Okay, so as per the Indian Oil Corporation report last year, 2 years back, it is 300 million metric tons per year. Okay, it is based on the number of vehicle usage. And last one is exhaust gas emissions. Okay, so even in this case of pollution norms, so previously we followed. Okay, so before this 2020 April, we followed BS4. Okay, Bharat stage 4 only norms. But we don't know why immediately from Bharat stage 4 to Bharat stage 6. So we are not moved to the Bharat stage 5. So straight away we move to the Bharat stage 6. Okay, so that much difference is there if we are going to use the conventional fuel. Okay, due to this more emission, more pollutants emitted to the atmosphere. Okay, so because of that four reasons: fast depleting, frequent increase in fuel cost, vehicle population, and our last point is pollution norms. Okay, so due to this reason we go for the biodiesel. Okay, the significance of biodiesel, it is a renewable fuel, high cetane number, oxygenated fuel. Okay, if you that is the most important properties for the biodiesel, oxygenated fuel. If you are going to use the biodiesel derived from vegetable oil or any other bio source, okay, the fuel itself, some oxygen is there, means it is going to enhance the combustion, complete combustion. But as combustion takes place, complete combustion, even if you are going to supply the excess air, okay, so almost maximum we have to control, reduce the pollution, CO2, hydrocarbon, NOx. Okay, so if it is a combustion enhanced, NOx only dominate. Okay, but other harmful gases will be reduced for this case of oxygenated fuel. Then biodegradable, non-toxic, non-hazardous. Okay, and finance-wise, that every country, okay, so their GDP rate is based on the oil. Okay, oil export only. But here, suppose you are going to, instead of, we are not going to be able to export, but we reduce the import. Okay, so in our country, instead of export, at least to reduce the import means it in this GDP rate also increase. Okay, these are the significant advantage of this biodiesel. Okay, so these are the some non-edible oils. Okay, it is not used for the what is this oil, refined oil for cooking purpose. So cotton seed oil. Okay, so in the South India, okay, even Coimbatore also previously called the monster of cotton. So we are using this cotton seed oil. Then similarly Pungam oil. Pungam oil also not used for the cooking purpose. Okay, so cotton seed oil content around 26% maximum. If you are going to use the Pungam oil, 35%. Okay, then rice bran oil. Actually, previously it is not used, but nowadays recently the Purna oil. Okay, so Purna oil is from the rice husk only. The rice husk also 4 major layer. Okay, for example, inside the rice, okay, pericarp, seed coat, okay, nucellus, and the last one layer is alluron. Okay, these 4 layer only used for the to extract oil from the husk. That is called bran. This 4 layer only called bran. That's why from this layer only we are getting the rice bran oil. Around 23% yield is there. Okay, then tamnu oil. Okay, tamnu oil is nothing but a pinai. Okay, so most of the seashore area it is available. One beauty of this tamnu oil. Okay, for example, suppose we are using oil for the lamp. Okay, so from this lamp, if it is the flame height. Okay, if you are going to use some other oil, flame height will be less. But in this case of pinai oil, okay, pinai oil, it will give some height and brightness also. Okay, that means calorific value is more. If you are going to test it in this lab, compare with the other oils, okay, so their calorific value is more. That's why it gives some brightness with the flame height also more. Okay, so these are the some oil. Other than this non-edible oil, okay, mustard oil and other karanjo oil. So many oils are available. Seeds are available for the biodiesel conversion. Okay. Okay, before going to start this process preparation. Okay, so in this basics, anyone having any doubt, any clarification? So regarding this oil and the demand need.
No, sir.
No, okay. So if you have any doubt, you have to raise at the end. Now move to this preparation. Okay. So any seed, okay, any seed or any source, even from the algae, even if you are going to use the algae also, raw algae, okay, in the powder form. So this is source. Here actually it is mentioned the raw vegetable oil. If you are going to use the algae, okay, and that algae used in the form of powder or in the form of liquid form, water maybe. Okay, so we have to use the test free fatty acid. Okay, so based on the free fatty acid only we have to use the acid catalyst or base catalyst. Okay, if it is less than the free fatty acid content, okay, so less than 4, okay, free fatty acid content less than 4, so directly we go for a single phase method. Single phase method means directly we have to add the catalyst NaOH along with the methanol. Okay, so along with the methanol, we have to use the NaOH as a base catalyst. So we go for the transesterification. This is the first step. Whether we go for a single phase or a 2-phase method. If it is that content acid content greater than 4, so we go for the 2-phase method. 2-phase is nothing but esterification and then transesterification. So that's why it is called 2-phase method. So in the case of 2-phase method, even for single phase and 2-phase, we have to add the methanol. Okay. So for example, the ratio is for 1 liter. Actually, it is dry lander method only. But in case of in normal ratio, that methanol is for 1 liter, it is 200 ml of methanol. Okay. For 1 liter, we go for 200 ml of methanol, and this acid catalyst as well as base catalyst. So depending upon the and the free fatty acid content. Okay. So 20 ml to 25 ml or even 30 ml also we have to use either for transesterification we use the NaOH. For esterification we have to use the that acid H2SO4. Okay. For two-phase method, if it is free fatty acid content greater than 4, we have to add this methanol and H2SO4 in the ratio of for 1 liter raw oil, 200 ml of methanol, and according to the content, fatty acid content, we have to use 25 or 30 ml of H2SO4. Okay. So for esterification process. So in the esterification process, the methanol and H2SO4 considered as a solution. Okay. So the solution is added with the preheated raw oil. Okay. And then it is heated in the conical flask or whatever container available for the esterification process. So it is heated up to below the boiling point of the methanol. Okay, normally we go to heat up to 65 degrees centigrade. Okay, for 2 hours. Okay, simultaneously we have to use the stirrer, either magnetic stirrer or manual stirrer for stirring purpose to enhance the reaction rate. Okay, so once that the process was over for 2 hours, we have to keep the what is this oil, okay, for natural cooling for 8 hours. Okay, then whatever is separated, okay, that is called oil, remaining is glycerin. Okay, then the same oil we got used for the transesterification, second phase. Okay, that esterified biodiesel is once again used in the transesterification for the further process. Okay, so by adding the once again that methanol and NaOH with 200 ml and 25 ml ratio. So here also once again we have to preheat and raise the temperature up to 65 degree. Okay, for 2 hours. Then we keep it for natural cooling for 8 hours. Okay, then after natural cooling, okay, and the impurities and all removed as a glycerol. Okay, biodiesel is washed, water wash. Okay, by using normal water. Then it is pure biodiesel is separated in the separating funnel, and the methanol is recovered during washing process. So this is a common procedure for the biodiesel production from the vegetable oil or any other sources. Okay. So first phase is we have to identify the fat content. Then we go for either esterification or transesterification, and then glycerol is settled in one stage. And after washing process, that methanol is recovered. Okay, excess methanol and pure biodiesel is used. Okay. Then calculation for the free fatty acid content. It is example that formula directly we got to use the free fatty acid content 28.2 into volume of NaOH used for the titration into 0.1 normalities. Okay, so divided by weight of the sample. Okay, for example, how much is considered for the this process? For example, 1 ml. Okay, suppose you are going to consider 1 ml of vegetable oil with 10 ml of isopropyl alcohol. Okay, for color indication, so we have to add the phenolphthalein indicator. Okay, so here if it is single phase method less than 4, so by using this formula we have to identify whether that content is free fatty acid content less than 4 or greater than 4. So less than 4 we go for a single phase method directly transesterification. If it is greater than 4 we go for the esterification process. Then this procedure for this transesterification. Okay, so solution for transesterification means single phase method. Okay, in the case of single phase method we got to use the base catalyst NaOH 5 gram. If it is in the pellet form means 5 gram, otherwise if it is liquid, okay, 0.1 normality means we got to use the 25 ml. Then methanol 100 ml. Okay, if it is very low free fatty acid means we got to use 100 ml, or if it is concentration is more we go for 200 ml for 1 liter of oil. Okay, so then it is heated up to 60 to 65 degree centigrades. Okay, so at the maximum 2 hours this conical flask. then we have to wait for natural cooling 8 hours. Okay, then we have to get this for the end biodiesel, and then it is byproduct. Okay, after separating this three-way conical flask, that is called glycerin. Glycerin also useful byproduct, even for transistor process. Suppose it will take some extra cost. Okay, so that is managed. For example, per liters petrol or even diesel is 80 rupees, means if we go for biodiesel preparation, so more than 80 rupees cost for preparation. Okay, in batch production in the case of laboratory level. But if you go for the mass production, it may be balanced. But anyhow, the cost is compensated with the useful byproduct of the glycerol. So cosmetic and medicinal purpose, we have to use the glycerin. So that's why it is compensated. Okay. So directly we move to these actual topics of the algae. Okay. So algae also prepared by using the transesterification or otherwise called enzyme. Okay, enzyme method. Transesterification or enzyme method. But algae is a natural resource available. Okay, in the saline water, or sometimes artificially we have to develop, cultivate in the small pond, or sometimes called some other method. We'll see one by one. Okay, so this is also similar to this biodiesel from vegetable oils, but instead of vegetable oils, we have to use the renewable source, algae. Okay, so algae as a renewable source, it is extracted. Okay, so any other extraction method what we followed in this vegetable seed, we have to use the same extraction method. Then it is produced by either esterification or transesterification, or by using enzyme method. Okay, so laboratory level for what is this identified the yield content. Okay, we go for the enzyme method. But the mass level, if we want to produce more, we go for the transesterification process only. Okay, so from the algae, okay, algae also grow in this photosynthesis process. Okay, it is grow in this saline water by using photosynthesis process. Then it is extracted and then produced by using this biodiesel production method, transesterification method. Then glycerin is a byproduct is used. Then oil. Okay, biodiesel from the algae is used as a renewable fuel for the transport purpose. Okay, so you see the image in the seashore area. Okay, it is settled. It is settled due to the wave. Okay, due to the tide or waves, it is settled at some corners or some places. Okay, it is depending upon the number of days from this beginning. The size growth rate is more. Okay, so more growth means more yield also available if you are going to use it as a fuel. Okay, so algae is a large and successful group of organisms. Okay, flourish in a sea, fresh water as well as damp places on the land. Okay, so these are the places where we go to cultivate, where we go to develop the algae. Okay, so it contains chlorophyll. Okay, so but this chlorophyll can produce their own food. It is a base for the aquatic food chain. Okay, so the algae is a food chain for the aquatic. Okay, so natural occurrence in all water bodies. So not only saline water, even all water bodies. Okay, it is grow in their own as a chlorophyll. Okay, but compared with the normal water bodies, saline water means that growth rate, okay, and easy to cultivate by artificial also. Okay, so if you are going to use, okay, suppose we are going to use the algae, the benefits means it is renewable source. Okay, it is renewable and that growth also very fast. But for example, if you are going to use the what is this karanja oil or cottonseed oil, okay, even that penny oil, whatever may be, we have to wait for that season. It is going to be available in the season only. Okay, but in the case of algae, all maximum it is available. Okay, so it is throughout the year, it is maximum it is available. So grows fast. So you are not going to wait for that season. Okay, so that is added advantage if you are going to use as a algae as a resource for the biodiesel production. Okay, then it consumes CO2, so it is recycling is carried out, can be used as a fuel and food and energy, used as a energy source, major source. Okay, so it is that flow chart for the production of this biodiesel from the algae. Okay, it is cultivated in different places, a different method. Then it is harvested. Okay, so after harvesting, we get directly expeller used to extract the oil, or we have to keep it in the biomass. After drying, we have to keep it in the biomass in powder form. Then after preparing this in powder, okay, so we have to use the hexane. Okay, so we have to add the hexane. If you are going to use the enzyme method, okay, lipase, as a lipase, that hexane method is Soxhlet. Okay, so it is going to use in the Soxhlet for the preparation. So instead of transesterification process, okay, we go for enzyme method, and that algae in the powder form after drying and crushing, the powder is used in this Soxhlet apparatus with the hexane. Okay, so that is also gives a maximum yield for this this extraction. Okay, and this lipid form, then it is from this top, that is glycerin, value added byproduct. So after this lipid form, we have to use the transesterification. Okay, so it is the impurities and all removed. Impurities and all removed in the transesterification process. Then FAME, FAME, fatty acid methyl ester. Okay, so from any resource, any natural that seed or source, okay, final product is we called as fatty acid methyl ester only. Okay, the another name for the biodiesel is fatty acid methyl ester. Okay, so the source is different, either algae or vegetable oil or biomass. Okay, or even that animal fat also sometimes we have to use for biodiesel preparation from the fat. Okay, but the final product is called pre-add acid methyl ester. Okay. Okay, so this is algae to fuel. Actually, various methods are there. The common method is enzymatic extraction, and another one is called ultrasound assisted extraction. Okay, so the ultrasound also high expensive method, but enzymatic extraction is a simple method only. So we have to use in this dry powder form of the algae, used in this Soxhlet apparatus, adding this hexane. Okay, we have to get maximum of 60 to 75% yield. Okay, on this conventional method only, oil expeller, solvent, supercritical fluid extraction, after that transesterification. But this enzymatic method, okay, more attractive and most yield method for this biodiesel preparation from the algae. Okay, so enzymatic methods, algae and enzyme. Okay, so used directly to convert this algae into biodiesel. Okay, so previously if it is alternative, okay, alternative means instead of diesel. Okay, instead of alternate. Okay, for diesel, that alternate means we go for the biodiesel, biomass, ethanol, methanol and all for gasoline engine, petrol engine. Okay, so biodiesel only for CA engine. Then hydrogen also. Okay, some vehicle directly hydrogen also used in this vehicle. Okay, this alternate fuel other than this conventional engine. So directly some other sources also is there. Solar. Okay, then windmill. Another geothermal, hydroelectric power plant. This and all another alternative. Okay, so it's no need to depend on this diesel generator. So we go for another source for the renewable source. Okay, then biofuel source, first generation. In first generation, we have to use the crop, food crops. Okay, sugar cane waste. So this and all for the first generation biomass, from the biomass converted into biofuel. Then second generation only that jatropha vegetable oil. Okay, so jatropha olden days it is famous. Now even railway also cultivated the jatropha for this converting jatropha oil as a biodiesel. Okay, but due to some reason, okay, so even imagine it won't be withstand more time now. So almost based on the fuel price, okay, battery vehicle, okay, so battery vehicle, solar operated vehicle, so the and all come into this picture with a cheaper rate. Okay, so it is in the middle, the biodiesel, biofuel and all in the middle stage. Okay, advanced is in battery operated, solar operated vehicles and all come into this picture in case of alternative. Okay, for diesel we go for battery as well as solar. Okay, the third generation only this type of fuel, algae. Okay, third generation only this type of algae fuel. That algae also you see here, it is estimated third generation designer 5%, first generation around 33%. Okay, as a biodiesel 14%, second generation 11%. Hello, hello.
Yes, sir. Hello.
No, no. It's audible, sir?
Yeah, sir. It's fine, sir. Fine,
Audible,
sir.
sir.
Audible, audible.
Okay.
Audible, sir.
Okay. Okay, thank you, sir. So this is from the third generation and that algae. So around 37%. Okay. From the algae, it is that's why it is called important as well as bring into this recent source for the biodiesel preparation. Okay, compare with the that vegetable oils as well as the biomass. Okay, so if you are going to concentrate more on this algae, you have to cultivate this algae in the seashore area, make use of these resources, converted into useful biofuel with more yield and more useful fuel instead of diesel. Okay, so this is a preparation stage. Okay, even we have to cultivate in small scale in the small pond or small tray. Okay, so this is after this algae, it is keep it in this dried form. Then we go for this powder. That powder only converted into that oil by using this hexane in the oxalate apparatus. Okay, so either we go for esterification or trans-esterification depending upon the fat content. It is not always less than 4. Sometimes if it is grown in this saline water or grown in the normal water, okay, the content may be varied according to this free fatty acid content. Okay, we have to use the that algae either esterification or trans-esterification. But the best way we directly go for the enzyme method. Okay, so by using lipase. This lipase enzyme method is the best option, converting this algae into biodiesel. Okay, so one device also available by using this chamber. Okay, counting chamber. So we keep it in this cell. How it is developed, cultivated. So what is the range? Okay, so based on depending upon the range only we go for whether it is advisable or not for biodiesel preparation. Okay, either we go for esterification or trans-esterification or even that enzymatic methods. Okay, the formula is count total count by number of blocks. Okay, so number of block means some structure we have to use for the that counting. Okay. This is open pond. Okay, instead of this lake or river or seashore, so we have to use the open pond. We have to cultivate. So only one source available, small sample is available, means from that sample itself it is grown. Okay, by photosynthesis grown in fast rate. Okay, that what is this? From this only we have to develop. Okay, so this system is called open pond system. Okay, so other method also is available by using tube or some other tray. Okay, so whatever is convenient according to the location. Okay, so we have to use this cultivation method. The open pond also small scale um, production of this algae, cultivation of this algae. Okay. So the range, so based on the composition, it is available. Okay. Range 25 to so many components are there. Okay. So for example, 25 to 33, isocrescid. Okay. Cylindrothebica, 16 to 37. So like this, so many compositions are available. These are the that morphology. Okay, you see here from this morphology, another 4 content is there. Okay, but the total composition in this content range is given. Okay, oil content of the microalgae. Okay, so it is characterization. After characterization, these are the range. Okay, for the algae available, oil available in the algae. Okay. So maybe this method is given, but we go for the enzymatic method, means in the lipase as a catalyst. We got to use a lipase catalyst. But in this alkali catalyst, acid catalyst, NaOH, H2SO4 for the transesterification process. Okay. By using NaOH means alkali catalyst, H2SO4 acid catalyst. Okay, and lipase only for that enzyme method. Okay. And last one is supercritical method. Okay. Supercritical method means we keep it in high temperature, high pressure. Okay. So directly without any catalyst, if you are going to keep this that source, okay, and that algae in powder form or liquid form, you have to keep it more than 500 degrees centigrade, pressure also around 20 bar. Okay, in the supercritical reactor, we have to use the supercritical reactor for this oil extraction, oil preparation. So instead of normal conventional esterification, transesterification, and enzymatic method, okay, if you go for supercritical method, in the supercritical reactor, okay, SCR, supercritical reactor, temperature 500, pressure 20 bar, okay. So maximum 75% yield available without any catalyst. Okay, so these are the methods available for that biodiesel production from the algae. Okay, so that's all about this algae and methods to convert algae into useful biodiesel. Okay, fatty acid methyl ester, everything from whatever source. Okay, it is used for converting that oil. That oil is called fatty acid methyl ester, FAME, fatty acid methyl, or esterified version of that oil, esterified version of algae oil, esterified version of cottonseed oil, esterified version of rice bran oil, like this. It is esterified version. From raw oil to biodiesel means called esterified version of this oil, that particular oil, or otherwise called fatty acid methyl ester, or commonly we got to use the biodiesel for IC engineering. Okay, so that's all about my presentation. So this is that structure is there. Okay, and the advantage of this lipase catalyst method. Okay, so very selective, converted free fatty acids are converted into biodiesel, low reaction time in conventional methods, easy of separation, higher yield. Okay, in the form of homogeneous as well as heterogeneous catalyst. So even we go for that octane number, cetane number by using this homogeneous form or heterogeneous form and the fuel supply. Okay, so this is adaptable one. If you are going to use the biodiesel, don't bother about the homogeneous or heterogeneous. So directly used in this fuel supply system, either injector or DPI, direct injection system. Okay, so we have to use this fatty acid methyl ester as a fuel in the conventional engines. Okay. Thank you. Thank you for all. So do you have any clarification, any doubts?
Participants, any queries?
Somebody asked in this
Chat box, there are questions, sir. I will read out, sir.
Yeah. Okay, it is available.
Vivek Pandey has raised for generating 1 liter of biodiesel, how much algae required? A rough thumb rule you can give, sir. Yeah. 1 liter
From
of
algae
biodiesel.
for example, it is depending upon the method, what method we are followed. For example, the supercritical reactor, okay, 75% yield means, okay, if it is not 1 liter, if it is algae in the form of powder only, after drying these leaves, okay, it is a powder form means, example 1 kg. Okay, if it is 1 kg, half liter is maximum. Okay, half kg is maximum. Jay Krishnan.
Sir, that photobioreactor details. Photobioreactor
What's
design
that?
details.
Supercritical. Which photos are for biodiesel reactor?
Yeah. Some reactor.
Supercritical reactor, sir. Hello.
Yeah, sir. Yeah, sir. You can explain, sir.
Supercritical reactor means, if it is biodiesel production means, either we have to use the acid catalyst H2SO4 or base catalyst NaOH. Okay, but if you go for the supercritical reactor means, we have to keep this source, even algae in the form of powder or added with the hexane. Okay. So we have to keep the temperature super critical reactor means, it is maintained at 500 degrees centigrade. Pressure is around more than 20 bar means without catalyst. Okay, and that raw oil is converted into biodiesel. Okay, so within 1 hour, no need to wait for another 2 hours. But we go for conversion method, 2 hours is required. But in the case of supercritical reactor, 1 hour is sufficient, but without any residue. So directly everything is converted into biodiesel.
So what facility you have, sir, at your university?
University here, that
For
enzymatic
the algae
method.
cultivation, the testing facility.
So in Shastra, that ASK, Anusandhan Kentra, and research center available there, the pot cultivation only available. From the pot cultivation, within 5 to 10 days they are cultivated, then used for the converting this dry
What is
leaves
the yield,
into
sir, for 10 days? What will be the approximate yield, sir, of algae?
in number of pond size. It is number of pond size. Even per pond, 500 gram means more than 10 ponds they are cultivated means 2.5 liters like this, 2.5 kg like this. So if you suppose you are going to use in the 2.5 kg, around 50% means 1.25 liters possible from algae.
Okay, sir. Okay.
Okay, sir.
So if there are no questions, sir, we shall end this session, sir.
Okay, sir.
We think some chat box, they have given many questions, sir, more of generic in nature.
How to get
Okay, sir.
Yes, sir.
Hello. Okay, sir, Dr. Mohan Raj, sir, thank you for joining us and presenting details on the cultivation methods, then the statistical data you have provided of the oil content from algae, etc., the generation of biodiesel, etc.
Okay. Thank you very much, sir.
We thank you, sir, for your expertise and joining this FTP. I thank you, sir.
Thank you to all participants for your presence here, and thank you for the coordinators of these adult programs for giving a chance to explore my ideas in this event. Thank you, sir, once again.
Thank you,
very much.
thank you, thank you,
Thank
thank
you.
you.
Thank
Thank
you.
you,
Thank you.
So, dear participants, the session now ends. First session is we will end the first session and we will join after the break, 11:45. Tribological aspects as per the schedule. We will have the next session. Thank you for joining.
Okay, thank you, sir.
Sir, Mohan Raj, sir, you can leave, sir. Thank you, sir.
Thank you, sir. Thank you.